Today we will be taking a look at complex numbers and roots. If you haven't done so already, I'd like you to pause the video and attempt the warm-up problem. There's 2 questions, and hit play when you are ready. For number 1, you were asked to simplify the radical. Remember, when we're simplifying radicals, we want to rewrite it using the product property, and we want to look at factors that are perfect squares. So 1, 4, 9, 25, 36, so on and so forth. If I think about the factors of 126 and its perfect squares, other than 1, I know that I can multiply 9 times 14. 9 is the perfect square of 3, and I have that 14 remaining in the radical. Now you can always check and see if it's simplified all the way. If I think about the factors of 14, I have 1 and 14, 2 and 7. None of those are perfect squares greater than 1, so yes, it is simplified. Number 2, you were asked to solve the equation using the square root property. The first thing that we should do, and some of you struggled with this on your homework, was you need to isolate the term being squared. When I look at this equation, the x squared is not by itself. It's currently being having 4 added to it. So I need to get it by itself by subtracting 4. We're essentially doing the opposite. And what you do to one side, you have to do on the other. Meaning that I'm left with x squared equals -4. Well, now I can take the square root of each side. But remember, when you take the root of each side, so not just when you're simplifying, because I already knew this was a positive, but when you actually take the root of each side, you need to include a plus or minus out front. So I have plus or minus the square root of -4. Now, some of you may have seen this and thought, hey, there's no solution because you can't take the square root of a negative number. That's what you were taught in algebra. However, you are going to learn today that that just means there is no real solution, but there are 2 imaginary solutions. And that's what our focus is going to be on today, how to find the imaginary solutions. We need to start off by talking about what an imaginary unit is. So what is an imaginary number? We let I denote the part that's imaginary, and I is equivalent to the square root of -1. We also need to know what I squared is. This will help us later when we're solving. So I squared, well, if I know that I is the square root of -1 and I'm squaring that, well, the square root and the square cancel each other out, meaning I squared is -1. So just one imaginary unit, so I to the first power would be the square root of a -1, but I squared is a real number, and that number is -1. We're going to start off doing something that should be fairly familiar. It's simplifying radicals, but this time notice how all of the radicals are negative. Starting with A, I have the square root of -2. The first thing that I'd like you to do is use product property. We're going to rewrite this as the number, so 2 times, let's pull out the negative as a -1. So 2 times -1 does give us -2. Again, I didn't change the value, I just rewrote it as the number and -1. And the reason why I did that is because using product property, I can rewrite that as the square root of 2 times the square root of 1. The square root of 2 is already simplified, so I'm just going to rewrite it as the square root of 2. And the square root of 1, I know, is equivalent to I. giving me my final answer as square root of 2i. Part B. Once again, I'm going to rewrite it as the number, so 4 times the negative 1. I'm separating the number and the negative sign. By doing that, I can rewrite it as the square root of 4 times the square root of negative 1. We want to simplify this radical if we can. The square root of 4, well, that's a perfect square of 2, so I can just rewrite it as 2 and then I. Notice how with none of these, I'm not putting a plus or minus, and here's the reason why. I am not taking the square root of anything. I already have a square root and I'm just simplifying it. It is only when you physically take the square root of each side that you must include the plus or minus. Alright, part C, I have negative 75. Let's do it again where we split it up. I have 75, my number, and a negative 1. Remember, the goal is to rewrite this. We're simplifying the radical as an imaginary number. So splitting this up, I have the square root of 75. That's my real number. And then my square root of negative 1. This will give me the negative, or excuse me, the imaginary component. Simplify this radical if you can. Well, I know that I can rewrite it as 25 times 3. And then the square root of negative 1 was an I. Keep going. The square root of 25 is 5, and I have the square root of 3 because the 3 was not a perfect square. Don't forget to put that I there. Let's just double check, make sure it's simplified all the way. Square root of 3 is simplified because the factors of 3 are 1 and 3, and none of those are perfect squares other than 1. Alright, part D. Once again, we're going to simplify the radical. Now I want you to notice there is a number out front. All this is saying is we have negative 3 times this radical. So when I rewrite it, I'm going to scooch this over here, I have negative 3 times, breaking it apart using product properties, 16 times negative 1. Okay, that gives me square root of 16 and I. All of these are being multiplied together. Let's just check and see if we can simplify the radical. So the square root of 16 is a perfect square of 4, meaning I have negative 3 times 4 times I. Negative 3 times 4 is a negative 12 I. Alright, I'd like you to pause the video and try these 3 problems. The first one, you ended up with 2 root 3i. The second was 12i. And the third, you would end up with negative root 7i. Feel free to pause the video and go over my work if you got that incorrect. Okay, now we are going to solve these quadratic equations using the square root property, since some of us did have a little bit of difficulty, and this time our solutions will be imaginary. Remember, the first step that you should always do when using the square root property is isolate the term that is being squared. So when I look here, my term is already isolated, meaning I can just take the square root right away. Now, because I took the square root of each side, I need to include a plus or minus. So I have x equals plus or minus the square root of negative 81. Using product property, I can rewrite that as plus or minus 81 times negative 1. The square root of 81 is 9, and the square root of negative 1 is I, meaning that I have 2 solutions here. One of the solutions is a positive 9i, and the second is a negative 9i. So I have 2 imaginary solutions. For part B, The first step should be to isolate the term being squared, so that's x squared needs to get by itself. First thing I need to do is subtract 75 from each side, giving me 3x squared equals a negative 75. Now I need to divide by 3 because x squared still is not by itself. Now I can take the square root of each side. Because I took the square root, I need that plus or minus out front. Using product property, you can split this up as plus or minus the square root of 25 times a negative 1. The square root of 25 is 5, and then the square root of negative 1 we know is I. So I have two solutions here. The first one is a positive 5i, and the second one is a negative 5i. All right, part C. Once again, we need to isolate the term that's being squared, so I'm subtracting the 10 first, and now I need to divide by 3. So I get x squared equals negative 12. Go ahead and take the square root of each side, but remember that means I need a plus or minus. I'm going to simplify this radical and write it in terms of imaginary numbers. Oops, I meant to write times negative 1. So I have plus or minus the square root of 12, I, because the square root of negative 1 is I. Now you can simplify this further. If I think of the factors of 12, there is a perfect square other than 1, and that would be 4. I can rewrite it as 4 times 3, right? So really I have plus or minus 2 root 3i. One of the solutions is a positive 2 root 3i. The second is a negative 2 root 3i. I'd like you to pause the video and try the next three. Number 1, you should have ended up with plus or minus 6i. 2 was plus or minus 4 root 3i. And 3 was plus or minus 5 over 3i. Feel free to pause and check your work if you got it incorrect. Now we're going to talk about the difference between real numbers, imaginary numbers, and complex numbers. Real numbers would be anything that we're used to. So a negative 1/2, 0, 7. The square root of 2 is a real number. It has an actual numerical value. Pi, remember pi is 3.14, blah, blah, blah. It has an actual numerical value. So any number is a real number. Any imaginary number would be the square root of some negative number. So let's say negative 2. That'd be imaginary. Anything that has an I in it, so I is imaginary. Or we could even have a positive I. We could have a negative I, like negative 5i. A complex number, which is what we're going to be dealing with now, is a combination of real and imaginary numbers. Now this form is in the form a plus bi, and that's what we see here as well. A represents the real part, and the bi represents the imaginary part. So an example of a complex number would be 3 plus 7i, or 3 minus 7i, 4 minus I, 4 plus I. Anything as long as the real number is out front and the imaginary is afterwards. If you did write 7i plus 3, I just flipped these two around. Technically, yes, this is still a complex number. There's an imaginary component, there's a real component, but it is not in the proper form. So again, A comes in front, it's the real number, and then B is the imaginary number that comes second. A plus bi.